All right, so our lesson for today is on net change and average rate of change. Our key topic is the average rate of change, and then the net change is kind of related to that. So the big idea of the average rate of change is that it's just a fancy way of saying the slope between 2 points. So average rate of change is just slope, okay? And so our formula for the average rate of change, we kind of have three of them here, and they're all really the same thing. So rise over run, I'm sure you guys have heard of before, and that's slope. The other way to look at it is y2 minus y1 over x2 minus x1. I always just remind people that the y's are the rise, so remember to put the y's on top because that's the rise, and then the x's are the run. And then f of b minus f of a over b minus a. Remember, if it's in the f of, that's really our y value, and then the numbers inside are our x values. So once again, that's really saying the same thing in just a little bit of a different way. Now, what's a little bit different on this, as opposed to other ones you may have, other problems where you may have found the slope, is that I don't give you the whole point. I kind of just give you the x values in the function. So you're going to have to figure out the y values on your own. So I'm just going to use these two x values, and so we'll do f of 2 first. So f of 2 is 2 times 2 minus 5. So then f of 2 would be negative 1. All right, and then we have to do f of 5. So f of 5 would be 2 times 5 minus 5, which would be 10 minus 5, which would be 5, okay? Okay, so then we'll go ahead and find our average rate of change and our net change kind of at the same time here. And so, let me get some more space. We're going to do f of 5, which is 5 minus negative 1. And so it's like I'm subtracting my two answers there. The 5 here is my y2, and that's my y1, over my x value, so 5 minus 2. Okay, so just subtracted my y values on top, subtract my x values on bottom. All right, and so then I'll just simplify that. So on top here I have 6 over 3. Now I'm actually going to stop there because this actually tells me one thing here, is that numerator, once I do my subtraction, is the net change. It's just the y2 minus y1, and so I already know that that's 6. And then my average rate of change, I'll call it average rate of change A rock, would just be 2. So 6 over 3. Now, some of you may be thinking here that slope of 2 is not surprising, because if you look at the original function, it's a linear function, and the slope is 2. So actually, if we would have picked any two x values in the world, then the average rate of change would have come out to 2, because on a linear function, the slope is consistently 2. However, on number 2 here, you can see that we have a quadratic function, and on this one, the slope is actually not consistent. So I can't just say that it's going to be negative 3. I actually have to do the work here, okay? So we're going to do f of negative 2 first. So that would be 1 minus 3 times negative 2 squared. So PEMDAS here says that's 1 minus 3 times 4. So 1 minus 12 would be negative 11 for f of negative 2. For f of 0, it'll be 1 minus 3 times 0 squared. So that's really just 1 minus 0. So f of 0 would be 1. All right, so now I'll do my rise over run here. So we'll go ahead and do y2 minus y1 over x2 minus x1. So I have the numerator at 12 here, the denominator at 2. So then I know my net change is just the numerator there. It's 12. And then my average rate of change would be 6. It's 12 divided by 2. All right, next up we have number 3 here, and this one is a little more tricky because they're not asking us at numbers, they're asking us at these expressions. But we can use the same technique here. So let's just find f of a first, and so that's 4 minus a squared. And then let's find f of a plus h next. So that would be 4 minus a plus h squared. Now on this one, I'm going to want to simplify it, so I'm going to go ahead and write that twice, a plus h times a plus h. We want to FOIL that, so it's a squared plus ah plus ah is 2ah, or 2 plus h squared there. All right, now I'm going to distribute the negative. I would always recommend that you do that FOIL before you distribute the negative, so it's going to be 4 minus a squared minus 2ah minus h squared. All right, so now I have my f of a plus h set up as well, and so now I'm going to go ahead and do my average rate of change here. and I'll do my net change as well. So that is going to be y2, and so y2 is this whole expression right here minus y1. So y1 was the what I got when I plugged in a, all over x2 minus x1. Now you can see on the bottom that these a's cancel out, and then that formula right there should look pretty familiar to you. That is actually the difference quotient. So that is where the difference quotient comes from, is we're kind of finding the slope between some imaginary point a and then some other imaginary point, which is a plus h, which is a little bit bigger. Okay, so now I'll go ahead and simplify this. So I'm going to distribute the negative. I'm going to go ahead and write that up here so I don't have to rewrite everything again. And then I can cancel this stuff out. So the 4 cancels out with the negative 4, the a squared with the negative a squared. I'm left with negative 2ah minus h squared over h. Now I'm going to stop right there and point out that I have now my net change. My net change is just going to be the numerator there, which is negative 2ah minus h squared. And for my average rate of change, I'm going to divide everything by h here. And so that'll leave me with negative 2a minus h. All right, next up here, same idea. We're going to find the net change and the average rate of change. So from negative 2 to 1, so I would go to these x values and find the point on the graph there. So negative 2, and that would be 1. And so the net change is just, or actually I'll do the average rate of change first. So that is going to be, you can see the rise over run here. I wouldn't actually use the formula because you can just count the rise as 1, and then the run is 3. So that's my average rate of change. And then remember, the net change is just the numerator there. So that would just be 1. All right, so then same idea over here. So from negative 4, which is right there, to positive 4, which is right there. See, it's up 3. And then over, it's from negative 4 to 4, so that would be 8. So then my net change would just be 3. All right, next up we're going to look at increasing versus decreasing and then local maxes and mins. So the key on these is that whenever it's asking you where it's increasing or decreasing, it's the x intervals. And so I'm going to say it's increasing from here to here. And so what is that? 1, 2, 3, 4, negative 4 to negative 3. And then you can see it switches to decreasing, but then it switches to increasing again right here from negative 1 to 1. And then it switches to decreasing, and then it switches again right here. I think I meant for that to be from 2 to 4. If you say that that's like 1.8 to 4, I kind of agree with you. So I think I meant it to be 2 to 4. All right, so there's my answer for increasing. So it's all the spaces. So like I said, I'm going to say here it's increasing as you read it left to right. Here it's increasing as you read it left to right. Here it's increasing as you read it to left to right. So I describe them with the x values. For decreasing, it's kind of the other ones. So I would say from there to there. So from negative 3 to negative 1 on the x values. And then also from there to there, which is from 1 to 2. All right, I'm going to clear this off so we can then look at the increasing versus, or sorry, the local maxes and the local mins. So a local max is a point that's higher than all the other points to the right and to the left of it. So it's really always kind of the top of a hill. So our local maxes are right here and right here. We're usually going to describe these as points, and so I'll go ahead and describe it. So the first one will be negative 4, 2. And then the next one would be 1, 1. So then the local mins would be down here, just the bottom of a valley. So I would say that that's a negative 1, negative 4, and then also at 2, negative 3. All right, so then the global minimum is kind of the overall lowest point on the graph. So I would say for that is right here. That happens to also be at a local minimum. And so I would say that that one is -1, -4. And then the global maximum is the highest point on the graph, so that is up here. So that one didn't qualify as a local max because there's nothing to the right of it, but it is going to be a global max because it's the biggest point on the graph. And so that one would be, what would that be, 4, 4. All right, so then same idea over here. So then my increasing, I have kind of to start right here. So that would be 1, 2, 3, 4. So then -4. And I'm just describing this with x values from -4 to -1. And then also from 1 to 3 right here. Decreasing would be the other ones. So from here to here. So it would be -1 to 1. And then also from 3. And that one actually, I don't know if that's going on forever. I'll say that stops at 5 there. If you said to infinity because you think that keeps going, that's fine too. All right, so then let's erase that and let's look at our maxes and mins. So the local mins are at the bottom here. So I see it right there is the only local min I see. So that one's going to be 1, -2. And then the local maxes, I have this one and that one. So that's going to be at -1, 3, and also at 3, 2. So those are coordinate points. The global minimum, actually I'd say that's a tie. We have that one and that one. So I would say -4, -4, and 5, -4. And then the global max would be this one up here. That's the highest point on the graph. So it'd be -1, 3. All right, lastly here, it says that a man is running around a circular track at 200 meters in circumference. So an observer uses a stopwatch, and so we have the data there. So it's asked for the average rate of change, average speed. And so we're just going to keep doing our y2 minus y1 over x2 minus x1. Now I know my x values are 68 and 152, so I'm going to subtract them. And then I'm just going to get my y values from the chart here. So that would be 800 minus 400. So then I'm going to do, I got 400 on top. On bottom, it's 152 minus 68 is 84. So 400 divided by 84. And that is 4.76. And if you want it would be meters per second. Okay, so then same idea for the next one, 412 minus 263. So I have 1600 minus 1200. So 400 on top again. And 149 on bottom. And that would be 2.68 meters per second about. So I'd say this person's not a very good runner because you're supposed to keep your speed kind of consistent there. And so I would say he's not staying on track, if you know what I mean. All right, last up here, what is the man's average speed throughout the whole time he is running? So I think it's obvious here that that we're talking about the 412 and 1600 to finish it. But this is kind of a trick question because where does he start the race? Well, he actually starts the race at 0, 0. So a little trick there, even though it wasn't on the chart, we kind of know that every race starts at 0, 0. So I'm just going to do 1600 divided by 412, and that's 3.88 meters per second.